Okay, so let's start with reading the problem statement first. Then we'll look onto the example which we have over here, the constraints that they want us to follow, and then we'll move on towards this implementing. Basically, you know what this class refers to?
Yeah.
Class LRU cache. Okay, so so that's completely fine. We are basically implementing a data structure that is least recently used cache, and let's
Sorry, I
go
have a
through.
question. So, data
Yeah.
structure is that like array list map, right?
Well, data structure could be of any type. You could have different variables. Let me give you an example. A coordinate consists of x axis and y axis, so it will contain two variables. Apart from that, if there is a shopping cart, it would contain list of items. That is another data structure. Data
Oh,
structure could contain anything.
mhm.
It could vary from problem to problem.
Oh, okay, I see.
Okay. Um, let's start with the problem statement.
Mhm,
Implement the LRU cache. LRU cache, we have functions written over here in capacity.
mhm,
Initialize the LRU cache with positive size capacity. Okay. Int get int key. Return the value of the key if the key exists. Otherwise, return -1. Okay. Void point put int key and int value. Okay, it's giving you a key and it's giving you a value. You need to store that value on that specific key value pair. Okay, it's fine. um, Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of the key exceeds to the capacity from this operation, evict the least recently used key. Okay, I see. What you do, get and put in order of one time complexity. Okay. We have input LRU cache, put, and all of that. Okay, that's fine. We have another input. Let's read what's the input style. We have a string, a list of strings. LRU cache. Okay, put, get, put, get. Okay, so we are using these commands to determine what action is to be performed. Okay, so let me give you a brief example of what the input basically is. We have a first list which whose length is, let's count, 1 2 3 4 5 6 7 8 9 10. Okay, let me open a marker. Okay, yes. So we have this list and its length is, I believe, 1 2 3 4 5 6 7 8 9 10. We have 10 elements in this list,
mhm.
and we have another list as well. This is also containing 10 elements. What it basically refers to is each index of this list, the first list, is corresponding to the command in the second list.
Mhm.
LRU cache is being used to create the object, and the size being given to us is 2. Put is being used to put value. The key is 1 and the value is 1, as you can clearly see in, as explained here.
Mhm.
Okay, so we have these multiple calls. Whenever there is a put, there is a combination, there's a tuple, I would say, a key and value pair. Whenever there is a get, there's only a key which we are looking for.
Mhm.
Okay, and the output is null, 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 1 null, -1 null, -1 3 and 4. Okay, so why is this output being displayed? Coming towards this point, these are the values which we are returning by performing these input commands. Let me change the color. Okay, so these commands, whenever LRU cache is called, there is nothing returned. So
Mhm.
we are returning null. Whenever a put is called, nothing is being returned. But whenever we are calling a get, there's something that we are actually looking for. Like we called get for the index 1, and we were looking for this value specifically. So this
Oh,
is how.
hang on, I have question. So,
Yes.
when it's called LRU catch, then there's nothing return. But then when it call for put, then there's when it call for get, then there's something return. I'm a little bit confused about how is calculate the output.
um, how is it calculating the output?
Yes.
Okay, let me show you these functions. Let's erase these first lines. Okay. Um, each function is supposed to either return something or not return something.
Oh, okay. So,
Okay.
for example,
So
like each of the put and get supposed to return something or null, right?
yes, get is supposed to return. Let me give you. LRU cache is not returning some anything. There's this second you, if you can see this square box that I made.
Mm-hmm.
Get function returns an integer value.
Oh,
So
okay.
that's why we are putting this over here. And void is basically referred to as null, or we can call it none.
Oh,
Void is itself nothing.
mm-hmm.
So we are referring to each return value of these inputs.
Mm-hmm. I have question though. So there's no void in the output.
There is no right in the output. Basically what they are expecting, there are certain types of questions, and there's one thing that they don't follow any specific convention. In certain questions they would expect you to print statements, and they would be comparing on the print statements that you are actually written or your code is printing. In this scenario they are comparing or checking it on the link list, in the list that you are sending it. In the end, this list, they're comparing whether your results are correct or not based on this output.
Mm-hmm.
So it varies from problem to problem.
Mm-hmm.
In certain problems, you're supposed to print statements, but in this problem, you're supposed to give the output of all these commands, and that's it. This is what they are expecting from us.
Oh, okay. I see.
Okay. Okay, let me clear this up. Let's go through the explanation as well. Okay. As it was clearly mentioned that the first command is for each of this linked list. This list is
Mm-hmm.
referring to each command over here,
Mm-hmm.
and it has also commented that whether it is returning something or not.
Mm-hmm.
So this is what we are basically doing.
Mm-hmm.
Okay. So what we need to do for the time being is we need to, okay, let's read the constraints as well. The capacity could be between these value, the key could be in this, okay, and value could be this. Okay, it's fine. We'll look into that. Are you familiar with what constraints are in on lead code?
Uh, it means like when I code, I need to include the solution to cope with these constraints, right?
Yes. Okay, it's like they, whenever they are testing on your code, they would be entering values in this range. So you don't have to expect output outside this range or focus on values. What would happen if the key value would be greater than 3000 if it's written?
Oh, okay.
So you don't have to worry for that part.
Mm-hmm. Okay.
Okay. So let's let's give you a brief overview of what we are going to do now.
Mm-hmm.
They are asking us to implement, what should we say, a dictionary, and what they want us to do is we would be given a specific size. In this sample input, it is 2. We
Mm-hmm.
need to create a dictionary with this size.
Mm-hmm.
Initially, its values would be null. Now, what we need to do whenever it calls a put, we take the value, in this case, which is this one, and put it on this index which it is referring to. On the second time it called put, we placed 2 on index 2. When it called get, we took the value on index 1. This is how we are working basically on this thing. So let's refer to how. Yes, there's a question.
Sorry, I have question. I just want to
Yes.
double check that my understanding is correct. So the put method always gonna have two input, right?
Yes.
Oh, okay. So what is the first value on the put? Is it the LRU catch?
uh, in the first it is key,
Oh, okay.
and for a dictionary it is key and a value pair.
Oh, okay. So why the get doesn't have the key?
Can you repeat what you just said?
Oh, so why the get the LRU catch dot get doesn't have the key? Oh, because
Dot
we
get
get to
has
get the value only, right?
dot get has key, but it does not has value. On the
Oh,
basis of key, we return this value through get.
oh, okay. Ah, okay. I understand now.
Okay, so this is how things have to work in this specific scenario.
Mm-hmm.
Okay, let's read these explanation and try to understand. We have built a basic intuition that when this function is called, we'll create a dictionary in it of size 2. When put is called, it will put one value on index 1, two value on index 2, it will return value on index 1, it will insert value 3 on index 3. This is how things have to be. But now we are going to understand how it actually works, because if you remember, there's one thing which it restricted us was the capacity needs to be constant. We are not allowed to change this thing.
Mm-hmm. What does it
The
mean by
capacity.
the capacity need to be constant?
Okay, that means that the size of the dictionary needs to be same.
Oh,
We are not allowed to change it. We would be actually using the same uh, value that we have. The size, let's say in this case we have our size was 2, so we would be let's just go through the explanation part, and you'll get to know why things are like this and how it is actually working.
okay.
So okay, let's okay, when this first LRU cache function was called, this object was created. A dictionary was created of size. A dictionary is expected to be created, whose maximum size would be 2. We cannot exceed 2. When this put function was called, the cache contains index 1
Mm-hmm.
with value 1.
Mm-hmm.
When this function was called second, index 2 and value 2 was inserted. Key value pair 2 comma 2 was inserted. When get was called, this value over here, this was returned.
Mm-hmm.
When LRU cache.put was called, what it is basically doing is it is replacing 2 with a value which was last time used. I mean, how can we say? Least recently used. The value which was, okay, let me give you an example. Let's assume there's a value, let me draw you something to explain. We have these, just for basic understanding, we have a list, and it has 4 indices, and we have the values 1, 2, 3, 4. What I basically did, I first called get on this one. Okay, so the value for this is 0. I mean, this is the most recent time it was accessed. Then I called get on this one. This had value 0. I'll explain to you what these values are. This was value 1. By what these values on top refer to, this value and this value, is referring to how late it was called or accessed last time. Let's move one step ahead as well. When 4 was called, I'm just giving you an example that 4 was called on this get function. This 4 would be given a value of 0, that this was called most recently. Since it was called 0, this would be called on 1. This was accessed one step back, and this was accessed last time accessed 2 steps back. If you get this intuition, this whole problem is very easy to solve. If
Sorry,
you
just want to double check again. So
Yes.
if it call for one, then it will go. Sorry, if we call for three, then it will get the value as two step back.
Yes. So what we are basically doing is, can you just repeat step by step what we are doing?
Oh, I'm a little bit lost in this list. So if the key is one, then yes, I'm a little bit lost. I'm still cannot understand the logic.
Oh, okay. Let me just redraw it to make it a bit clear. I'll explain to you how things would work when we will code. I hope so. It will be relatable more. Um, so let's draw that same list again. We have one, two, three, and 4. Okay. So I have these 4 values, and I have another list as well, which initially has 0, 0. I'll explain to you what it is referring to.
Mm-hmm.
0 and another 0. This means that all these indices were accessed most recently.
Mm-hmm.
The minimum this down, this value is the most recent it was used, or the
Oh,
most recent it was accessed.
sorry.
Initially, all of these are
I
zero.
just want to double check. So 1, 2, 3, 4 is just the index, right?
These are values. It could be there could be five on this index as well. Here the let me.
So 1, 2, 3, 4 is just the index, but the 0, 1 is the key, right?
No, no, these are the values. I'm not referring to the problem. I'm just explaining you the context. I'm not. Let's just forget what this was demanding from us.
Okay.
I'm explaining you what is the logic behind it.
Oh,
Then we'll code it. Assuming we have a list with values. These are the values.
okay.
1, 2, 3, 4,
Mm,
and we have another list which is referring to. Let me type a text. This is actual list. Can you see the text as
yeah,
well?
yeah.
Okay. And we have this one, last accessed. Okay, so this list has the values. So let me guide you through step by step. What I did, the first call, I called get function on index. I say, let me say 1.
Mm-hmm.
So this would return this value. Okay.
Mm,
So when I called this get function, it returned me this value. So this value, this 2, was used most recently.
mm-hmm. Yes.
So what we are going to do is we are going to keep the value which was accessed 0. This would be stayed as 0. This would remain 0. But apart from that, all other values which were present there, we'll make them 1. We'll increase them, increment them, that these values were accessed one step back.
So, for example, if we call two like get one, it will return two, but then this will be changed. The last access value will be changed to 0.
Yes, we will keep that value which was accessed same, whatever value it was.
Okay.
When I move another step ahead, you'll understand how things were. This is how the list looks like now. Now I called the same function get on index, let's say 3.
Mm-hmm.
So it would return this 5 value.
Mm-hmm.
So what I'll do is I'll replace the value which I just accessed with 0.
Oh, okay, I understand now.
This is 0, and now I will increment all these values, whatever values we had over there. um, this would become this would become 2.
Mm-hmm.
This would become 1. Since it was 0, it would become 1, and this would become 2. So
Okay.
if you can understand the logic behind this 0 is representing the minimum value in this array, is representing this was accessed most recently.
Mm-hmm.
Now the second number which was accessed is this one, and the third number which was accessed is are these two.
Mm-hmm.
So this was accessed very recently. This was least uh, less recent, and these two values, by number of ticks I'm referring to, least recently. So this is the main concept of this LRU cache. We have to implement least recently used logic. Can you build this? Can you did you got this intuition that what we are basically doing over here?
Yes, yes, I'm clear now.
Okay, so this is how we are going to proceed with it. Let me just show you this explanation as well. You can relate to it that
Mm-hmm.
what I'm talking about. If you can see here, we created this dictionary. It had 1 1, and this was 2 2.
Mm-hmm.
At this instant, let me draw it for you as well so that you could relate it much better. Okay, so what it basically did is at this instance, when 1 was added, this was most recently used, and 2 was used one step back on this instance.
Mm-hmm.
Is it this point is clear?
Yes.
Because 1 was added, whether it is addition or get call, whether it is put or get call, it is being accessed. So this was like this. When this was called, what changed was these values changed.
Mm-hmm.
This shifted to 0, and this 0 shifted to 1. This is how our least recently used order was. When I called this get function on 1, what it referred to was this. I was asking for this value, this one.
Mm-hmm.
Since it was on this index, we'll shift this value to 0 now,
Mm-hmm.
and this value is shifted to 0, and this 0 would be incremented. Whatever value there would have been, it would have been
Oh,
incremented.
wait, I have a question. So once you get the get one, which is one is the key, right? And you need to get the value. So the value should be the second item. Hang on, let me get the annotate. So, oh, can I hang on? How do I control? Okay, request a remote control.
Yes, okay, I believe you have
So,
access.
okay, so I thought this is the value. So when this asks for the key, then it has the key. Then this one should be zero, and this one should be one, right?
This whole array is basically referring to least recently being used. These are
Oh,
not key value pairs.
oh, okay.
The key value is in a separate variable. We'll call it cache.
Mm-hmm.
But we are maintaining history in another list.
Mm-hmm. Okay, I understand now.
Okay.
Oh,
Um,
I have question. So if
yes.
they just input like like one number, then how do you know which one is the number that will turn to zero?
Whenever the first value is being entered, we are referring to it as the, how can I explain? Let's say the first index. The values are being inserted in initially. Do you know that in dictionary there is no order? Mean there is no sequence actually.
Oh,
In dictionary, this could be possible that you are viewing it in this way, that one has this one and two has this two, but
yeah.
in reality it is not maintaining this sequence at all.
Oh,
Dictionary could have been like this. You could have two value key value in the beginning and one value in the end.
oh.
Dictionary does not support that.
So it doesn't matter. It just matter that which value is the most recent access turn into zero, and the rest turn into one, right?
uh, I won't call rest to turn into one. I would call increment the rest,
Yes.
because
Yes.
in this scenario there are only two values, so it is shifting, fluctuating between 0 and 1. But if you remember, when I drew four values, it went to 0, 1 and 2 as well.
Mm-hmm. Yes, I understand now.
So we would be keeping the value same which was last time accessed, and we would increment the remaining values.
Mm-hmm. Yes.
Okay. If you have any questions so far, we can have those,
Mm-hmm.
or we can proceed.
Okay.
Do you want to? Yeah,
Pardon?
or we? Yes. Are we proceeding, or we are sticking to this one as well?
No, please
Do you have any question? Okay.
continue to solve this. We have 1 hour. Is it all right if today's session is 1.5 hours? I think we just spent half an hour, so I can go another 1 hour if you want.
Okay. We can see if we could just complete it in an hour. We will. It's up to you. And if
Okay.
it
Yeah.
takes more time to for you to understand it, we'll.
Yeah. Yeah. I'm free the whole night tonight, so take as long as you could with this. I'm
Okay.
I'm just worried about your schedule because you have the class tomorrow, right?
Yes, but it's quite late. It's at 2 p.m.
Oh, it's 2 p.m. in your place.
No, tomorrow my class is at 2 p.m.
Ah, okay,
It's
okay,
later
yes.
than.
So please take as long as you need to help me with this question.
Yes, I'll try my best to just get through this, at least this one question
Mm,
uh,
yeah,
completely.
yeah, yeah.
Okay,
I still need to learn
so
to put on this.
yes, yes. Okay, coming towards this. Okay, so let me just is this let me just type in so that things are faster. Okay, so this is how it looked like initially
Mhm.
when this one was inserted. This looked like this.
Mhm.
Can you see these lists that I'm writing actually? Is it visible to you, the text that I'm typing?
Yes, yes.
Okay. um, so let me just place it over here just to make it more relatable. Okay. Okay, that's fine. When one was inserted, 0 0. Okay, no, this was 0 and this was 1. When 2 was inserted, this was 1 and this was 0. When 1 was accessed, this was 1 0 and this was 1. When 2 was tried to access, 2 was okay. So now we are putting 3. Since this 1 was most recently used, we'll delete this value and insert it on this index, and this would become 1 0. I'll also relate to you how each of this list is referring to.
Mhm.
Just give me a moment. Then when I try to put another value, it shifted from this to this. Okay, and -1, nothing found. It's 0 comma 1, the same. When 3 was accessed, it's 1 comma 0, and when 4 was accessed, it's 0 comma 1. I'll just draw arrows that each of these lists refer to. I hope this doesn't get deleted. Okay. Um, so I'm basically showing each state of our least recently used behavior, that how it is actually referring to.
Oh, okay.
-1 was not found.
Oh,
So
so this is just the number of the list of the recent use and the increasement.
yes.
Oh, okay.
Okay. Um, I guess I made a few extra lists, I guess. Okay, this was referring to this one, this,
So
return.
why the 0 and 1 change the position?
Yes. Can you ask a question?
Sure, sure.
Elaborate.
So I thought like because of the order in the dictionary is not important, so you can put the 0 and 1 and you how you like. So why in this list the 0 and 1 change?
Okay, so what I would also maintain with this thing is, let me give you an example how I would actually implement it. That's a completely relevant and true question, that how would I know that which index is referring to which key value?
Yeah,
And I
yeah.
was also thinking on that. So basically, I did all of this to make things simpler. I
Mm.
would, do you know a tuple in Python?
Yes.
Okay, so there would be a tuple.
Sorry.
We
Tuple is something that cannot be changed, right? So the data is fixed.
Can you repeat it?
A tuple is a list that cannot be changed, right?
No, you can change those values as well. Let's talk about, if to make things simpler, we could also use 2D list. If
Mm-hmm.
you're okay, so let's make it 2D list. We have key value and we have the least recently being used.
Mm-hmm.
Okay, then we have another key value, which is 2. Then we have least recently used.
Mm-hmm.
Okay, so this is how things are.
Mm-hmm.
Let me erase this extra part. Okay, so initially this is how things are after step this. No, no, not this one. The one below this. This one. One was accessed most recently, and 2 was accessed one step back.
Mm-hmm.
Is okay. So it's clear till this point. When put was called, and I was not allowed to insert another index because the size was 2, which was it on its maximum capacity. What I did, I found, I looked for the maximum value in this index. Let me draw it with another pen. this I just checked on this value, these values, and searched for the maximum value. Since this was the maximum value, what I did, I overwrite on this index. I get the key from this part, which was 2. So I now know which key I have to replace with. The new value, this 3 comma 3, would be replaced with this key value pair.
Hang on. I I don't understand it for a little bit. So let me see. So in this part, so we are. Hang on. Where is? Let me get the annotate option. Mm, okay. So this one is hang on. So you get the key 1 0. It's just the access. So it's just the access. When is the last access, right?
Thus, if you can see, these single quotes I'm using to refer to key,
Oh, okay.
and the second index is referring to the least, I should say, least recently used.
Oh, okay. I see. Okay. I see. I understand now.
So
So,
when this 3 was called, what I would simply do is search for this value on this indices. I find this one. So I place 3 on the value, the key value, which was 2. And
mm.
I also change it over here. I make it 3, I make this 1 0, and I make this 0 1. I just made it a whole mess. Okay.
So,
Um,
so why I don't understand like why they replace the number 2 with 3? Uh, because it's the key, So I don't understand why they replace the key with 3, because it's not the location. Hang on. How do I say this? It's not like the last access. I understand like how the last access incremental, but I don't understand why they replace the key.
yes, this first index is referring to the key which are in our dictionary, and the second is referring to the least recently used part.
Mm.
So when this 3 was inserted, our most least recently used one was 2, this thing. So what I would simply do, I would replace this 2 by 3, this key value. It
Mhm.
was 2 over here, I replaced it with 3, and
Mhm.
I reset its least recently accessed value with 0, and
Oh,
I increment. So this is how things would go like.
I'm not quite understand like why. So here we have two pair, right? One pair. Here, let me see. Let me read this again. So why do we have two pair here? Like what this pair and what this pair do?
Can you repeat what you just said? Which pair?
Yeah. So why do we have two pair of this and this here? Like where is it come from? I'm a little bit lost.
Okay, okay, okay. This pair is referring to this position, this 1 comma 1,
Oh,
and
okay.
let me draw with another pen. This it's, okay, it is this place is now referring to where we have it, this 3.
Mm-hmm.
So this combination of these two values is referring to an index, or I should say a key in a dictionary.
So this one is also the key and value, but it's in here.
In this whole block, this is, you can say, this is key, and followed by, I should say, least recently used, LRU.
Oh,
This
okay.
was key value. This
Mm-hmm.
is key and least recently used.
Mhm. But why do they have two elements? Because I thought like in a dictionary you only have like key and the value, like just two elements.
In dictionary, yes, we have only two things.
Yeah. But why here like we have two elements?
No, this is not a dictionary. This is a list that we are following. We are using it for the purpose which is related to dictionary, but this data structure is a list.
Oh, okay.
This is list.
Ah, okay.
I'm referring it to this key and LRU pair, but it is actually not a list. Oh,
Okay.
actually not a dictionary. Actually not a dictionary. My bad.
Ah, okay. Okay. I see now.
Okay. So this is how things would go. Just to should I explain it one more time with
Oh,
this
yes. I'm
method of
a bit confused. So in here, like there are only two values. So it should be just like each time you call, there should be just a key and list recent use, right?
yes,
So let me try to simulate to see if I understand you correctly. So in here,
yes,
if it's you put in 1 1, so it will take the key is 1, and the least recent use which is before it turned to 0, right?
yes,
So the next one is 2 2 because the key previously the key is 1, so it doesn't matter. So this key is so the previous one key will be turned into one, and it still keep one, and the least recent use in now one, and then we have the new one which is two two two, which is so the two two will be two, and the zero because it's just call, and this one is get one, so we get the key in here. So so in here it will be become zero because it just get called in here, right? So far I'm all right.
yes. Yes, that's fine. I had just one question. Where is this two coming from?
Oh,
This two is
two
referring to.
put two two, right?
Okay. So this whole thing would be in one list. These yellow brackets. Can you see this?
Oh, oh.
This is referring to that one, and this two is referring to that two. I'll just type in these things in a clear way. Let's hope the things get resolved.
Mhm.
Just to explain how things are working. Okay. Just give me a moment. I'm typing. Okay. So it's nothing. So we have then one and two, and we have zero. Okay, let me just explain these two lines, then I'll proceed with the further. Um, okay, I just really. Okay. So this is referring to this point in time. This is referring to this point in time. So what is happening is we have one as a key.
Mm-hmm.
Since it was inserted, the least recently used value was set to 0. This value.
Mm-hmm.
Okay.
Yes.
When insert, or I should say put, was called on 2 comma 2 was sent, this 2 came in,
Mm-hmm.
we set its value to 0, and the value that was corresponding to this one was incremented here.
Yeah.
So these are the initial two steps that we have so far followed. If there's these two lines, just these two, we haven't proceeded any further.
Mm-hmm. Yes.
Okay, this these two steps are clear, that how these it is
Yes.
working
Oh,
like this.
I just want to have one last question. So here is if it's three three, then this list is still keep still. Oh, wait. So this one will increase to two now, and this one will increase to So this one will hang on. Let me see. Yes. So it will increase to two, and this will increase to one, and now we have another element is three three. So it could be three
No,
zero, right?
no, this is things would be a little bit different. Okay, I just erased it again. Um, Okay, I cannot read. Okay, just let me type in the what it would look like after this line,
Mm-hmm.
and this is what I'm referring to. Okay, so when this would be called, it would remain one would remain same. Its value would be turned to zero, and two value would be incremented. Okay, I hope you can see this part.
Yes, yes.
This line will make these changes to the list. Okay.
Mm-hmm.
Now coming towards this is the most critical part which actually makes how things would work.
Mm-hmm.
So since the most recent least recently used was this value, since it is 1, we'll replace it. How we'll replace it? The value would become, let me just type in, um, it would be like we have 1, we have 1 and its value is 0. Okay, no, its value is 1. And then we have 3 and its value is 0. um, can you see this, um, and build an intuition from this part?
Yes. So
Why?
so that is the pattern. I got confused. So how can you replace two with three? Like, what is the logic of replacement here?
Why actually, since why we are replacing, the point is LRU cache, the size of the LRU cache was 2. Okay, so we cannot add more elements in the dictionary. Now we have to replace those values. This is
Ah,
why it is called least recently used cache.
okay.
So
So here, it give you the size is two, so that like only you can have only two elements. So since this one is the least used, it will replace it with three.
yes,
Okay. Okay.
and this is how we'll also do it in the dictionary. We'll delete that key value pair which was corresponding to 2,
Mm-hmm.
and we'll add this new key value pair which we just received.
Mm-hmm.
And we'll also update, make this changes in this list, this second one.
Mm-hmm.
So this is how things would go.
Mm-hmm.
If this part is clear, you can tell me what, just to get an intuition, what would be the output of the list after this line is executed.
Okay, let me try. So we put 4, 4. So we have like this list here already. So this is the list used. So it will be like 4 here, and this will become one, become 0, right?
Yes, and
Oh,
the
next one
remaining would
become
be
one.
incremented.
Yes,
Yes, perfectly. This is
uh,
how things would work.
yes, that's great. Finally, I get it. That's good. Okay. So
Yes.
hang on. So let me try this. So it's get one, so it's not file because there's no one here, so it's returned -1.
Yes.
So why is
Yes.
oh -1, it's just not found. Okay.
Minus. Yes.
So get 3, then it return 3, get 4. Okay, I got it now. So we can
Okay.
move on with the code.
Yes. Okay. Um, so when this get 3, just to, when this 3 would be called, this value, this this thing would turn to 0 again,
Yes.
and this would increment. So this is the whole mechanism how the code is supposed to work. Building the intuition is the most important a person can code. Like, it's quite easy to code.
Oh, really? That.
Yeah, building this whole intuition is the most complicated. Just like we just decided that how our list should look like. That if you remember this key and least recently used value pair,
Mm-hmm. I.
least recently used pair.
Mm-hmm.
When you have built this whole intuition, it's you have everything that you need to code. So
Oh,
it's
okay, that's good. I have question though. So when I look into the solutions on the discussion, it said it
yes.
mentioned something about hash table, hash map, linked list. So how all of these concepts link to this? I don't understand.
Okay. basically dictionary works on this hash map. So you don't, or we don't have to worry anything about how dictionary works. This data structure, okay, my drawing is very bad. This data structure with curly braces works on this hash map thing.
What is
When
hash
you,
memory? Sorry.
okay, so what is a hash memory? Do you have any idea of how array looks like in memory?
How error?
Okay, how an array, A-double-R-A-Y, a
Yes.
list looks like
Oh
in
no,
memory.
no. Actually, I don't know how it works in memory.
Okay, so let's assume this is how memory looks like. These are the blocks. I can say I can store an integer value on this each index. Okay,
Mhm.
this is how it looks like. So an array is a series of blocks. This array would be this whole chunk of, we call it consecutive blocks. In memory, it has consecutive blocks.
Mhm.
But when it comes to dictionary does not works like that. Whenever you enter a dictionary key value, it generates a hash map. What is a hash map? It's a unique value which is not going to be same to any other value. When you inserted this one, let's just talk about the key value which you gave to dictionary was one. Um, let's say the dictionary name was K, and this is how you insert a new value to dictionary, correct?
Yes.
So what it does is, this one is a hash value is calculated, which would be like C6, 5, 9. It's very long. Okay. So this value is generated, which helps it to map this one to the memory location where this 2 is placed.
Mm-hmm.
Let me try to show you a hash map calculator from Google if I can find one quickly. Hash map. Why hash map has a great thing is, hash maps are unique. No matter what you do, it's completely unique.
Mm-hmm. But then with hash, I remember it cannot be reversed, right? So once you hash the table or the string, then how can you revert it to the original key and value form?
No, why dictionary uses it is, it just has to understand on which memory location it is being placed. So this hash value is used to help it out to land in that location.
Oh.
Let me give you an example. Do you know how? Let's give you an example. You are asked to store a dictionary. The most general way to store a dictionary was a list with all the names in a list. Okay, this is how we would store a list.
Mm-hmm.
Let me give you another intuition of storing dictionary.
Mm-hmm.
Let's say we have words as double A B, and we have another word as, let's say, ant. Okay, so we know in alphabets there are 26 characters only. So
Mm-hmm.
we have a tree, we have a depth which refers to these characters A dot 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 up to Z. This
Mm-hmm.
is the depth one.
Mm-hmm.
When I'm looking for any word in the dictionary, I look for this A. When I find this A, there is another list for this A. It is storing all these same up to Z.
Mm-hmm.
Since I have found this A has been accessed. Now I'm looking for this A on this level, one depth. It's called try. We call it a try. When this was also accessed, it goes down. So the time taken for it to access any word in the dictionary would be actually its length. Rather than traversing that whole list, the time taken to be calculating or finding that word is very optimal. This is why we use in certain scenarios dictionary, or we prefer dictionary over arrays or lists.
Oh wait, sorry. I just want to repeat the point to make sure I understand. So once it get so when you find A, then you store it in the cache, right?
When I find A, move towards one more depth. There's another array on a lower level. It's called, we are basically moving character by character. When I found this A, I know this is the path that I have to choose. Let's give you how can I plot you? Okay, okay. Let me just draw a basic dictionary how it would look like.
Mhm.
Clear, clear all drawings. Okay, so we have. I'm talking about. We have two words only. Um. Okay, my bad. A and T, and as I just said, A, B. So what it will do in memory, it will create one A.
Mhm.
This is depth at depth 0. This one A would have another A, and it will have another node which will contain N.
Mhm.
For this A, it will have another depth
Mm.
which
But
is called D.
this is graph, right?
What did you just say?
Oh, sorry. This is a graph data structure, right? Because it have node connecting to one another.
Yes, this is how I'm basically visualizing, making things easier to visualize.
Oh, okay.
It's not actually how it's implemented. So this is how. So whenever it tried to access this one word, it checked A on depth 0,
Mhm.
the place it found. Now it was looking for N. It found N on this level, then T on this level. So it only took 3 steps to reach this word. So this is the most simplest dictionary that I've made. There are thousands of words. So when you're traversing an array, you have to search for all those 1,000 words. Let's assume you have a dictionary with 10,000 words, and the word we are looking for is zoo. So when we are traversing and looking for zoo, it will take us, I guess, 9,999, assuming it is placed on last index. But
Mm.
if we were looking at this structure that I'm talking about, it would only take 3 steps for the structure to reach that point. It will look for the node which contains Z, then it will move towards the node which contains O, then it will move towards the node which contains O.
Ah,
And this
okay.
node will have all the information regarding that word.
Mhm.
So it is efficient in certain scenarios and not efficient in certain scenarios.
Oh,
So things are like this.
okay.
Um, a really well example for this is, there are as social security numbers, or we have national identity card numbers, which for the citizens of a country, and there's, I believe, too many citizens. Let's assume millions, hundreds of millions of citizens. So they cannot store those values in an array. It would take a lot of time for them to find a record of any individual. So storing that values, those records of individuals of a state, they'll use this dictionary technique because it will make things easier.
I see now. Yes, I understand it now. Thank you.
Yes, okay. So let's proceed with the coding part.
Mhm.
So coming towards, you want to code, or I should code and I'll just explain it to
Oh,
you.
please code, please code.
Okay. Okay. So we are basically looking for two things as decided. We will be having a dictionary for storing the key value pair,
Mhm.
and we'll also contain a least recently used list. Okay. And since we are having, okay, there's one thing that we need to know. To access the data members of a class, we need to create those with this thing called self dot. Are you
Yeah.
familiar with that? Yes.
Yes.
Okay. And the last thing that we need to do is self dot capacity. Initialize that from the value which we are getting from the user, from the function.
Mhm.
We have it.
Yes.
Coming towards get, whenever it is giving us, okay, so what we are basically doing is we'll first check if len of self dot least recent, recently used is less than or is less than equals to self dot capacity. Since initially this list is empty, we would simply append those values. Do you get this point that why I'm using this condition? It's
Mm-hmm.
meant for these initial steps, these two.
Mm-hmm.
Okay. So when we have this, simply dictionary of key is equals to um okay, this is get, sorry, my bad, I'm implemented it in get. This is supposed to be here. Put um okay, dictionary of key is equals to value and self dot and self dot least recently used dot append a tuple which would basically contain both those things, the key, which is in this case key, and the count would be initialized as 0 because this was accessed most recently.
Mm-hmm.
Else if len of okay, it should be 1. Okay, L if length is is equivalent to self dot capacity. This is a place where the whole logic comes in, that we have to actually check which was most recently used and replace that one with the value. We'll be looking for numpy max. Okay, in list comprehension we do it like this: self dot least recently used of colon comma 1 and max. Max would give me the value. And okay, numpy is allowed here or not? I believe we are not allowed to use numpy. Okay, so let's do it the typical way. For I in range len of self dot least recently used and max index is equals to -1 initially and max value.
Could you give me a few moments so I can read the code so far? I think I'm a little bit lost.
Okay, yeah, sure.
Yeah, give me a moment. Take a look at this.
Yeah, I'm also having a call. I'll mute myself for just one
Yeah,
moment.
yes, sure. Let
Um,
me take a look at it once. So, def boot if length of list reason use smaller than self capacity, then dictionary is key is equal to value, and a dictionary key is where is the dictionary key? Oh, I don't understand why the dictionary self dot dictionary key is equal to value. Yeah, so I don't understand this one. Why self dictionary key is equal to value? This one. Okay, sure. I'll read this and mm, self dictionary key to value then self this is use of key. Oh, I don't understand this one. So this one I don't understand. We shouldn't use a pen key.
Okay. Yes.
Uh, I have
Sorry for
uh,
that.
I have a question on the here like why self
Yes.
dictionary key is equal to value.
Okay. This call is basically how you insert a value in dictionary.
Oh, okay. Okay, I didn't know that. So that is always like the standard way for all the Python programming, right?
Yes. This is how it is. It works in dictionary.
Oh, okay. But then why key is equal to value? I thought like shouldn't like value is equal to value.
No, no. Basically, the hash map is being computed for this key value. This refers to where this value is being saved. As we discussed this whole logic about the dictionary thing,
Mm-hmm.
this key value would be used to access this one. This let me this one on the left side of the equation is the key, and the one on the right side, this second one, is basically the value corresponding to it. So
Oh,
this is how it
mm.
could be different. Not necessary that it should be same. It could be anything.
Okay, I see. Okay, so I understand that part. And max index. Okay. So why max value is equal float? I don't understand.
Oh yes, I was writing into it. Basically, I was giving it um,
Okay.
INF,
Okay.
float infinity.
Oh, what is float infinity means?
um just okay, minus float infinity. So what it basically does is, since we are looking for, if you remember the uh, least recently used array we were drawing, its second index, on every index the second part was referring to, it contained a value 0 1, in this case 0 1. If you recall that, we are basically checking the maximum value it had. So we need to compare and store the maximum value. When I'll dry run you the code, I'll explain it to you as well.
Oh, okay, okay,
Let,
sure.
okay, just let to draw it. Okay, this was one. It had zero, and we had two, and it had one. Assuming this is how things were. So
Mm-hmm,
what I'm basically doing is I'm traversing this whole array. I'm traversing this part.
mm-hmm,
I go onto this thing, and I check if 0 is greater than max value.
mm-hmm,
Initially it is, because I initialize this max value with minus infinity. So
mm-hmm.
yes, it is true. It stores, I will keep index 0, since this block refers to index 0. I will store it in this max index. I
Oh,
move on. Next step.
oh, I have question. So why max index is equal to minus one, right? Hang on, it's minus one or one? I cannot see.
Yes, it's minus 1.
Oh, so why? So why is it?
It is initially minus 1 because we haven't started yet. When I'll traverse through this loop, which I haven't completed yet, I'll initialize this max index value, replace this max index value with a value which contains the maximum of these two blocks.
Oh,
In this case, it would be replaced with one.
oh, okay. Ah, okay, I see now. Yes.
Okay. Um, yes. Can we proceed?
Oh, so why, where, okay, okay, I see. Yes, please proceed. I think I understand.
Okay. Let's just clear all drawings. Okay. So I'll just check if self dot least recently used of one is greater than max value. What I need to do is max value is equals to self dot recently used one, and max index is equals to, I could do another thing as well, but I'm not doing it.
Mm-hmm.
um, let's do it that way. It's more easy. Max max key, this would make things much simpler. So okay, max key is initially -1. Yes, max index would be replaced with, this is max key. So rather than storing the index, I'm directly storing the value. In this case, max key would contain correct 2, this for this 2, for deleting this 2,
Mm-hmm.
the drawing that I made very recently, if I can undo.
Mm-hmm.
For this case, initially I was saying that I can store the index of this code block, this block. But another thing that I can do is I can directly save this value as well. Basically, why I was storing that index, to access this value, I can directly save that value as well.
Mm-hmm.
Okay.
Yeah, look at this code for E in range. If so, okay. Okay, I think I understand this.
Okay. So if that's the case, it will um, assign it. Okay, and then delete self dot dictionary of max key.
Mm-hmm.
Okay. Now another. That's again my bad. We'll have to. Yes, we'll have to use the index the typical way, and I'll explain you why I'm just fluctuating between these things. Self dot dictionary, and I'll have self dot recently you last least recently used
Mm-hmm.
of max index. I basically had forgotten that I also had to update that value in the list as well. Anyways, delete. I just deleted that node from the dictionary. Now self dot dictionary of key is equals to value, and here comes another thing that we need to write, which is whenever we give this list, it increases the value apart from that one specific index. So so we have to traverse again for in range. Okay, let's just replace it first. Self dot least recently used of max index of 0 is equals to key. So I'm assigning the key to that max index. Okay, and self dot least recent rece used of max index of 1 is equals to 0. Okay, and now I have to apply a loop. Len of self dot least recently used if I is not equals to max index self dot least recently used of I of 1 plus is equals to 1. And I believe that's it in this part. We'll run it as well. Clear. Okay. So just go through the code once and then I'll explain how things are. Or should I explain first? And okay. So here I deleted in this loop. Let me explain. In this loop, what I'm basically doing is I'm looking for the maximum index
Mm-hmm.
which has that value which was least recently used. Once I have that max value, once I have that max index, what I do is I delete that value from the dictionary. How? Self dot most recently used, least recently used of max index of 0.
Mm-hmm.
Let me draw this list just so we don't have to understand how it actually looks like. 2 comma 1. Okay, so what I'm basically doing is this part. I cannot again draw. So this part over here inside these square braces is referring to this value because this was the one which was the maximum value which we could find. So this block is referring to this 2 and it will delete this 2 from the dictionary,
Oh,
this line.
yes.
So once I have deleted it, I'll then insert the new key value pair in the dictionary.
Mm-hmm.
So far we are on the right track. Now comes the tricky part. Now we need to change these values as well. Previously it was 2 over here. Now since we are inserting 3, so this needs to be changed. How are we going to change it? I first assign, replace this 2 with 3 simply through this line, this one.
No. Oh,
Yeah.
okay. So we use max. Yes.
And this line, I'm resetting its value to 0.
Ah, okay.
This is the step for that part which was least recently accessed.
Mm-hmm.
Now we have to increment as well in the rest of the array.
Mm-hmm.
This is 0, so we have to also increment it. This has been changed to 0 and this 2 also has been replaced with 3, for
Mm-hmm.
instance. Now we have to also increment in the other part as well.
Mm-hmm.
So this loop is being used for that.
Yes. I have a
Yes.
question in here. So hang on, let me open the annotation. So why self dot list? I don't understand like how you can replace two with three with this line.
Um, what can you just repeat it? What is
So,
the
so
doubt?
so, like here like you replace two with three, right? So I don't understand like how you can make it work with this line.
Okay, so I'm just actually replacing the 1. I initially had 1 over here,
Mm-hmm.
so I'm just assigning a new value to it.
Ah,
Why
okay.
I'm 0? Because this is the most recently used
Ah, okay.
as
So how about like how which line do you use to replace the two with three?
the replace which
Yes. So like when you update the value here, like like update the value to three. So how do you replace the value two here with three?
Okay. Yes, this line. Let me erase the extra part. This line is replacing the value 3.
Oh,
The
okay.
key contained 3, so I'm replacing the index 0. Max index of 0 is referring to this position. This
Okay. I understand now.
So this is what we are doing here. And in the loop below, we are traversing and increasing the least recently used.
Mm-hmm. Okay. I see. I understand now. Can you try to run the code to see the result?
We just need to do one thing,
Oh,
that is to implement get function.
oh, okay. Yes, sure. Please continue.
Okay. If if self dot dict okay, if key not in self dot dictionary of key dot keys. I hope so. I've written it correctly. We'll test it. Return minus one. So what it does is this is the key from the user
Mm-hmm.
in the function. I'm checking if this key is not found in
Mm-hmm.
self dot dictionary. Okay, not this self dot dictionary dot keys.
Mm-hmm.
What this function call does is it returns all the keys that are existing in the dictionary.
Mm-hmm.
For our case, it would be returning 1 and 2. So we are, if it is not in the dictionary, what we are supposed to do? Return minus 1. So we are using this condition for that part.
Mm-hmm.
And if it is found, we have to return it, but also update. So how we are going to do it? Um, this is going to be else block, or we don't have to write it as well. For I in range self dot, okay, len of self dot least recently used. If least least recently used of I of 0 is equals to key, then set its counter to 0. And if that's not the case, simply increment the counter. Okay, and we have to also return the value self dot dictionary of key. That's it. Okay. Um, let's go through this once and try to understand. This condition is being used to basically check if the key is found in our dictionary or not. Does it exist or not? If not, simply return minus one. If it does, this if block won't be executed.
Mm-hmm.
Then we'll come to this loop.
Mm-hmm.
Now we are traversing on our least recently used and checking if we have the key in the list. If we have it, what we decided was we'll reset its value to 0.
Mm-hmm. Yes.
And if it's not, we'll simply increment
Mm-hmm.
and we'll return that value which it was expecting from us. Return self.dictionary of key. So
Mm-hmm.
this is how things have to be. Let's just see if it's running fine. Okay. If self dot, how do you okay, it's okay. Oh, recently used of I of 1. My bad. Okay, I've made another mistake over here. Why haven't I used this I in all this part? This here as well, here. Okay, I have used it over here. Um, yes, yes. And self dot Least recently use of I of 1 is greater than max value. Runtime error. How is it a runtime error? Okay, my spelling mistake. Nice. RECENTLY. I've made really bad mistakes. And how I've made these mistakes recently used. Okay, yes, it's fine. This is okay. Another mistake self dot least recently used. Okay, delete self dot dictionary of list index out of range. Max index was not found. Okay, I see. If it's not found, um, max value was minus float. This was greater. Yes, it should have been found. Let's just check it for once. We have print max index. Okay, max index was should have been I and not that. Okay, so it just ran. I made quite a lot of mistakes because I wasn't actually executing it. So this whole thing worked fine. Can you view it and see that this is I had made basic mistakes as spelling mistakes and indices and all of that,
Oh, I
but the
have
code is
question. I don't understand like what the E here stand for.
which part can you just
Oh,
hover me
like
line number.
yes. Oh, okay. I see it. The look here for E in range of length of this reason. Oh, okay. So it's the oh, okay. Ah, okay. I understand. Okay. Could you help me send me this code to text file or whatever file that's suitable? Then I'll try to reread it. And
Yeah.
oh, I have questions. So do you have time tomorrow? We could do another session tomorrow if you like.
Um, I believe since I am not sure whether I would be available or not, can we
Sure, sure.
hold on? Can you just ask tomorrow for that?
Yeah, yeah, sure, no worries. So I'll go online again around 10 tomorrow, and if you can make it, let me know. Then we can have another session at 10:30.
Yes, we can do that.
Okay, yeah. So it's last minute thing, don't worry. So anytime around 10, if you can make it, please let me know. Except for Sunday and Saturday because I have another study group at that time. So anytime during the weekday, if you want to have a session, let me know. Then we can have it.
Okay, sure. I
All
see.
right.
Yes,
So
we can.
please help send me this code and thank you so much. And let me know your schedule, then we can continue with the rest of the lessons.
Yeah, sure.
Today was
Let
very
me.
productive. Thank you so much. And I'll take off now. Bye bye.
Okay, sure.